Welcome to today's Explainer. We're diving straight into one of the absolute most awe-inspiring forces on the entire planet, volcanoes. But, we're not just going to look at the usual explosions and lava flows. We're actually going to unpack the incredibly counterintuitive way these massive fiery events end up cooling the Earth's climate. It's a delicate balance, and honestly, it teaches us so much about our role as stewards of creation. Let's get into it. There's this incredibly powerful verse, Nahum chapter 1, verse 5, that says the mountains quake before him and the hills melt away. The earth trembles at his presence, the world and all who live in it. Think about that for a second. When we study volcanoes, we are quite literally watching the earth tremble and the mountains melt. It's a majestic, profound reminder of God's absolute sovereignty over creation. It just really highlights the breathtaking power of nature, doesn't it? And it certainly reminds us of the limits of human control.
So here's our roadmap for today. First, we'll cover the power of volcanoes. Second, exactly how volcanoes cool Earth. Third, we'll look at history's biggest volcanic eruptions. And finally, we'll tie it all together with stewardship, education, and morality.
All right, let's kick things off with part 1, the power of volcanoes and those incredible forces from within the Earth.
It all starts way, way deep underground with magma. We're talking superheated molten rock just rising up from beneath the Earth's crust. And when that subterranean pressure finally hits its breaking point, boom, it violently breaches the surface. But an eruption is actually so much more than just the glowing lava and ash we see in the pictures. There are these massive, invisible plumes of gases, specifically sulfur dioxide and carbon dioxide, that are ejected with such unbelievable force that they actually punch right up into our upper atmosphere. And the crazy thing is they can linger up there for months or even years.
So why is tracking all of this so crucial? Well, understanding these impacts is huge for a few reasons. It helps scientists actually predict short-term cooling trends in the weather. Plus, it lets us assess real threats to our ecosystems, to our agriculture, and even to the very air we're breathing down here. Ultimately, studying this stuff shows us how the Earth is just constantly being shaped by these massive internal and external forces. It helps us prepare, and honestly, maybe the most important takeaway is that it teaches us humility. It's a stark reminder that we're stewards of a world that is vastly more powerful than we are.
Moving right along to part 2, how volcanoes cool Earth, or as I like to call it, the unexpected chill of fiery eruptions.
Okay. So how exactly does a fiery, violent explosion create a planetary chill? It's kind of a brilliant irony, right? Here's the step-by-step. Once that magma breaks through the surface, those massive plumes of sulfur dioxide gas we just talked about, they collide with water vapor way high up in the atmosphere. That reaction creates these tiny, microscopic droplets called aerosols. And this is where the magic happens. Billions of these floating droplets basically link up to become a giant planetary mirror. They literally reflect incoming sunlight right back out into space. So, with way less solar heat actually reaching the surface, the whole Earth cools down.
It's basically this massive atmospheric tug-of-war. On one side, you've got those highly reflective aerosols acting like a giant shield, bouncing solar energy away and cooling the planet. But on the other side, remember, these eruptions are also pumping out greenhouse gases like carbon dioxide, which do the exact opposite. They act like a thermal blanket, trying to trap heat inside the atmosphere. So, with both of these intense forces happening all at once, you might be wondering, which one actually wins? Well, the sheer volume of those highly reflective aerosols completely overpowers the carbon dioxide. I mean, volcanic CO2 is just a drop in the bucket compared to human emissions anyway. Because of that, the short-term impact of a major volcanic eruption is almost always a massive, temporary chill over the entire planet. It's a cooling effect, not warming.
Now for part 3, history's biggest volcanic eruptions, where we track these global climate changes over time.
To really wrap our heads around the scale of these events, we have to look back at how they've actually altered human history. We're going to track 3 very specific, highly studied eruptions. We'll start way back in 1815 with Mount Tambora, then we'll jump forward to the modern era with Mount Pinatubo in 1991, and finally, we'll check out that infamous Icelandic volcano eruption, Eyjafjallajökull, in 2010.
The historical gravity of these events is just staggering. Take Mount Tambora in 1815. That single eruption pumped so many aerosols into the sky that the very next year, 1816, is literally recorded in history as the year without a summer. The sunlight was so blocked out and the weather was so anomalously cold that crops completely failed across North America and Europe. It was devastating. Fast forward to 2010, and you've got Eyjafjallajökull in Iceland. That one released such a massive, dense cloud of ash that it severely disrupted modern life. It grounded flights across Europe for days because flying through that suspended ash would literally destroy jet engines mid-air. No way you're flying through that.
But if we want the most perfectly measured example of this global cooling effect, we have to look at Mount Pinatubo in 1991. It's one of the most rigorously studied eruptions ever. Scientists found that the massive aerosol release from that single mountain dropped the entire Earth's surface temperature by 0.5 degree Celsius for over a year. Now, 0.5 degrees might not sound like a big deal, but to put that into perspective on a global scale, that is an absolutely astonishing, powerful shift in temperature from just one single natural event.
And that brings us to our final section, Part 4, Stewardship, Education, and Morality, connecting this science with a biblical worldview.
You know, a core philosophy to keep in mind is that education without morality will hurt. I mean, what is the point of being smart if we just continue to make bad choices? Understanding the mechanics of magma and sun-blocking aerosols is incredible, for sure, but raw scientific knowledge without a solid moral compass is just incomplete. We study the immense power of nature, not just to get smarter, but to actually cultivate the humility we need to be responsible, wise stewards of the earth.
When we approach our education with that kind of perspective, the result is truly beautiful. There's this wonderful promise in Romans chapter 8, verses 6 and 7, that promises peace of mind to everyone who keeps their mind spiritual. And that's exactly what happens when we engage with creation. We look at a volcano, we see its raw, terrifying power. We understand the intricate chemistry of global cooling, and instead of feeling fear, or maybe pride in our own scientific knowledge, we find profound spiritual peace. We recognize the brilliant, deliberate design of our world.
So as we wrap up today's explainer, I want to leave you with a provocative thought to chew on. As you continue your education, as you uncover more about these incredible systems governing everything from the Earth's crust to the upper atmosphere, ask yourself, what is the point of being educated if we make choices that hurt? Let your knowledge be guided by morality, and use what you learn to be a truly wise, humble steward of this amazing planet. Thank you so much for exploring this fascinating topic with me today. Keep that curiosity burning.